Hello and welcome to another video from our CBSE Class 10 revision program. This video is brought to you by Adams Academy, an expert online tutoring service for high school mathematics. This video is going to be a quick summary of the chapter Surface Areas and Volumes. In this chapter we'll learn how to find the surface areas and volumes of common three-dimensional figures such as cubes, cuboids, cones, cylinders, spheres, etc. There will also be problems involving combinations of solids and conversion of solids from one shape to another. These will become clear when we work out the problems that appeared in past question papers. But first, we need to revise the formulas for finding the surface areas and volumes. First, let's look at a cube. Here is a cube and we usually denote the side of the cube by A, right? So the length, breadth and height will be A. For a cuboid, you will have a length of L, a breadth of B and a height of H. For a cone, we denote the radius by R, the height by H, so this is H, and the slant height by L. For a cylinder, the radius is denoted as R and the height of the cylinder is denoted as H. And for a sphere, the radius is denoted as R. These symbols are going to be used in the formulas that are coming up next. Surface area of a cuboid is 2 times LB plus BH plus HL. Surface area of a cube is 6A squared. Curved surface area of a cylinder is 2 pi r h. Total surface area of a cylinder is 2 pi r into r plus h. Let's draw a cylinder here. For a cylinder, there are two types of surface area. One is the curved surface area. So that's the area of this curved surface of the cylinder, which is shaded here. The formula for curved surface area is 2 pi r into h, where r is the radius of the base. Now, if you want to find the total surface area of the cylinder, you need to add these circular bases. So there's a circular base at the top and at the bottom, each with an area of pi r squared. That's the area of a circle. So to find the total surface area of a cylinder, you need to add the curved surface area, which is 2 pi r h, and the two circular bases. So that's 2 pi r squared. This can be written as 2 pi r into r plus h, or h plus r. That's how you get this formula. Now for a cone, the curved surface area is pi r l. Let's draw a cone here. That's a cone with the radius of r, a slant height of l, and a height of h. So this is h. The curved surface area of the cone is going to be pi r l, and the total surface area is going to be the curved surface area plus the area of the base, which is pi r squared. So if you take pi r out, this is going to be pi r into l plus r. That is how you get this formula. For a sphere, there is only a curved surface area because it has just one surface. So the surface area of a sphere is 4 pi r squared, where r is the radius. For a hemisphere, you have a curved surface area which will be half of the surface area of the sphere. So the curved surface area of the hemisphere is going to be 2 pi r squared, because the area of a sphere is 4 pi r squared. Now if you want to find the total surface area, you need to add the area of this circle, which is pi r squared. So you'll have 2 pi r squared plus pi r squared, which is 3 pi r squared. That's how you get the formula here, total surface area of a sphere. Now let's look at volumes. Volume of a cuboid is L times B times H. Volume of a cube is A cubed. Volume of a cylinder is pi r squared H. And for a cone, it's 1 by 3 pi r square H. Volume of a sphere is 4 by 3 pi r cubed. And for a hemisphere, it's half of the volume of a sphere. So that's 2 by 3 pi r cubed. In this chapter, you'll need to solve problems involving combinations of solids. When you find the surface area of a combination of solids, you need to visualize the resulting solid and exclude the areas of surfaces which are not visible. For example, if you are combining this cylinder with two hemispheres at both the circular ends, the resulting solid is going to look like this. And if you are trying to find the surface area of this solid, you need to add only the curved surface area of the cylinder and the curved surface areas of both these hemispheres, because the circular bases of these three solids will not be visible. So you have to exclude the circular base of the solids and include only the curved surface area. The volume of a combination of solids is usually the sum of the volumes of the solids that are combined. Also, when you have problems involving conversion of solids from one shape to another, for example, if you are melting one cylinder and making two cones out of it, then the sum of the volumes of these two cones will be equal to the volume of the original cylinder. That's the principle you need to use in problems involving conversion of solids. The last section of this chapter talks about frustum of a cone. Now, frustum of a cone is a shape that looks like this, and it's obtained by cutting a cone by a plane parallel to the base. So if you cut this cone and remove the top portion, you will get a frustum of a cone. The formulas for finding the volume and surface area of a frustum of a cone are similar to the formulas for a cone. We have a frustum here with radii r1 and r2, a height h and a slant height of L. If you look at the formula for volume of the frustum, you can see that it's similar to volume of a cone. So you know that volume of a cone is 1 by 3 pi r squared h. That's 1 by 3 pi into h into r squared. For frustum of a cone, you need to replace this r squared by r1 squared plus r2 squared plus r1 r2. Curved surface area of the frustum. You know that curved surface area of a cone is pi rl or pi lr. For a frustum, this is going to be pi l into r1 plus r2. That's the formula here. To find the total surface area of the frustum, you need to add the areas of the top and the bottom circles. So this will be pi l into r1 plus r2 plus pi r1 squared plus pi r2 squared. Now here you have an expression to find the slant height. L is root of h squared plus r1 minus r2 whole squared. If you look at this figure, you can see that this distance here is going to be r2 minus r1 and this is h. So if you look at this right triangle, you can see that L will be root of h squared plus r2 minus r1 whole squared. Now that's the same as r1 minus r2 whole squared. So those are the formulas related to frustum of a cone. Let me end this video by sharing a few tips that you need to bear in mind when you do problems from this chapter. Liters and cubic centimeters. Very rarely you may get problems involving conversion of volumes from liters to cubic centimeters. You need to remember that 1 milliliter is equal to 1 centimeter cube. And you also know that 1 liter is 1000 milliliter. So using these two equations, you can convert from liters to cubic centimeters. Another conversion that you need to remember is from meter squared to centimeter squared, or from meter cube to centimeter cube. You need to remember that 1 meter squared is the area of a square of side 1 meter. So this is a square of side 1 meter, and this area is going to be 1 meter squared, right? You know that 1 meter is 100 centimeters. So this is 100 centimeters. So if you find the area of this square, it's going to be 100 centimeter into 100 centimeter, which is 10 raised to 4 centimeter squared. So that's the conversion between meter squared and centimeter squared. 1 meter squared is going to be 10,000 or 10 raised to 4 centimeter squared. Similarly, if you think about 1 meter cubed, 1 meter cube is the volume of a cube whose sides are 1 meter or 1 meter long. The volume of this cube is going to be 1 meter into 1 meter into 1 meter. That's 100 centimeters into 100 centimeters into 100 centimeter. This is going to be 1 followed by 6 zeros, centimeter cube. So that's the relation between meter cube and centimeter cube. 1 meter cube is 10 raised to 6 centimeter cube. And finally, when you do problems from this chapter, before attempting to multiply the actual values of the length, breadth, height or radius or whatever, always simplify both sides of the equation. For example, if we have a problem that talks about converting a cylinder to a cone, volume of the cylinder pi r1 squared h1 is going to be volume of the cone 1 by 3 pi r2 squared h2. Now after you substitute the values of r1, h1, r2, etc., before actually multiplying the values, you should always look for common factors that you can cancel from both sides of the equation. That will make your calculations a lot simpler. We'll see how this can be done when we work out problems from past papers. With that, we have finished the chapter summary for surface areas and volumes. We look at CBSE question papers in other videos. For more revision videos, please like our Facebook page and subscribe to our YouTube channel. Thanks for watching.